Hi everyone, welcome to iSignal channel. So in continuation with the previous video, we have stopped until the RRC connection setup complete. Let's say it is here, right? Now, as a part of NAS L3 call, right? So E-Node decisions, how it is actually taking, we are trying to see here. Now to start with, when communicating from base station to EPC, which is MME, so the first message what it will go is initial UV, which carries the NAS PDU as well, right? So this complete message, if you try to decode, then we'll come to know about those things. But for that, when UV is actually sending the RSA, attach request, right? So those things we won't be able to see those things that we'll see in the Wireshark to understand better about it. But you can see here initial UV message, because this is completely E-Node logs. I will be trying to show those things. 046, correct? So which is for the RNTA, it is serving basically, and it is initial UV message, right? And the next one is downlink NAS transport and uplink NAS transport. Like that, it will continue, which means at the NAS side, at the EPC side, MM is communicating to S gateway, S gateway is communicating to P gateway. All these GTP message exchanges will be actually happening, right? So those things, and in addition to that, we will be having the NAS transport. It means when MME wants to send an authentication request, example, right? Means in this particular case, it is sending the authentication requests, but those things are actually embedded inside this because it is a dedicated NAS info which will be present. So here the authentication request and authentication response, so all these things will come into the picture, right? So that's what actually this particular message talks about. Downlink info transfer, right? Security things, because PDCP layer will come into the picture for checking the security, and this is DL info transfer, right? And correspondingly, how the scheduling is actually happening from the base station perspective in order to reach this particular message up to the UV, and specifically until the NAS. So it has to pass through all the layers whenever base station is sending dedicatedly. Now we are actually already into the dedicated mode of operation, right? So accordingly, the dedicated resources base station should give. So that's why you can see all the specific configurations and what are the parameters those are actually sending across the different layers. For example, MAC, right? MAC means we will think about scheduling, and also for which RNTA here, right? This is LCID, this is the first one, which means DCCH again. So 0 is the CCCH, and the 1 is DCCH, because everything it has to go in the dedicated mode of operation now, right? So as you can see, and physical layer PDCCH and PDSCH, and again scheduling PUCCH, because this is for the uplink, which means it may be the uh, authentication response, and scheduling link adaptation, right? MCS, CQA offset, PUCCH, which means it requires much resources in the uplink, right? PDCCH, which means uplink DC. That's why you can see PUCCH pushing RNTI number of bytes, right? From the air interface perspective, these are all air interface messages which are actually trying to satisfy this message or this message. Okay, so these are the things that we have to understand much more in detail. If you are having good knowledge in the PDCP and other air interface layers, okay, you'll come to know all these things very easily. So the prerequisite for this is you should understand the 36.321, 322, 323 and 36.331, right? The specifications. It can be any release, basically release 8 or release 10, because we are currently understanding LTE aspects. Okay, so you can see some of the things I'll try to show you. Uplink info transfer, right? Authentication request, authentication response. For example, for the DL info transfer, we are sending uplink info transfer, which is RRC, right? And downlink NAS transport, which is S1 AP. For that, we are sending something uplink NAS transport. Somewhere here you can see, yeah, UL NAS transport also will be there. This is downlink NAS transport. This is uplink NAS transport for a particular for the RNTA. This is S1AP message, correct? So once the authentication is done, so in this is actually carrying authentication, right? And all the preparations of the core network side, like GTP messages and also the GTP messages between MMES gateway and P gateway, the TAPN connections, and also the getting the data and assigning the allocation of the IP address. P gateway is talking to the DHCP server for getting the IP address allocation, dynamic IP address allocation, right? Until that point, because here we are not seeing any MME messages. So here actually the MME messages will start. Initial context setup request, which means in this particular case, means the security and everything is done. Authentication is done and security is done. And preparation of the GTP bearers are done at the core network side, which we cannot see. Those things we will see in the Wireshark packets. Okay, so that will be that is already captured actually. Now coming to here, the default bearer. Okay, so that will be sending here because this is S1AP, right? So MME is sending this message, it is receiving and encryption, right? This is at the RRC stage, which means UV and the base station. So that is initiating the security mode command and security mode complete. So those are the keys that is actually taking, all are actually generated. K node B, RRC encryption, RRC integrity key, user plane encryption, right? And security mode command and security mode complete, right? So for the security mode command, this is RRC. Now you can try to see in much more in detail. These are all the air interface messages which are actually currently happening, right? So for the security mode command, now UV, you are actually sending to the UV because you are a base station. We are inside the eNode B logs. Now you are receiving. That's why you can see this is RX TX SRB1 means for the base station it is TX, but for the UV it is RX. Now in the reverse way, if you try to understand, RX SRB1, which means security mode complete, is actually sending by the UV. That's why you can see security mode complete, which is RX in the SRB1, right? And UV capability inquiry, again the same things will repeat, which means how to send it over the air, and we are getting the UV capability information. This is RX again because base station is actually trying to receive it, right? Okay, yeah, I think this is the the fundamentals, and you can see the RRC, sorry, SRB2, which means AM configured. This is just an MO call or data MO data call, which is actually initiated from the UV. That is the entire scenario here. And you can see the SRB2, because of the reconfigurations, maybe a dedicated connection is actually required, right? In this, the PDCP, all the things will come into the picture. You can see EPS bearer ID for the RNTI 46, RSC connection reconfiguration, right? RSC connection reconfiguration complete. So with fully secured way, it has to go now. The security should be completely implemented, right from here. RSC connection reconfiguration until here, you can see RSC connection reconfiguration complete in this initial context setup response. So the one what we have seen above is initial context setup request. For that, now it is sending. It means now from the NAS level, when we are thinking, it is actually going as RRC connection, sorry, activate EPS default bearer context request, activate EPS default bearer context response. This is the ESM messages, and attach complete also would have already happened by this stage. Downlink info transfer, right? Whatever the things are actually necessary, those things will be taken care. Maybe a logs is little bit not in the proper stage, but at least that point. But whatever the things are actually required, those things have been taken care. So I think we have done some different activity. That's why another CRNT has been allocated, right? maybe we can see, I think we have disconnected and we are again initiating, or UV is going in the idle mode of operation and we are again triggering the random access. Maybe we can see some random access messages. We'll try to see before 47. So this is completely 47. This is completely 47. Show in the okay. So 46 is there. Now you can see we are actually releasing UV context setup release, which means it is not disconnected, but it has just gone into the idle mode. It is just context released, RSA connection release. So it is completed. Now we are initiating random access here, right? Okay. So yeah, I think it's a continuous analysis. Then we can see in further videos. Let's take the completion now and see in the next video. Thank you.